I'm Amir. Okay, so VAR in football is wild. FIFA's got this system that tracks like 150 million data points per game, cameras everywhere, tells you exactly where a player's foot was down to the centimeter. But here's the thing, even with all that data, the actual call, was it a foul, was it offside, that's still just a human deciding. And it's not just annoying, it's genuinely a fairness problem. As you can see in the World Cup nowadays, human refs tend to get things wrong, they get influenced, and in a sport where one call can swing a title or millions of dollars, that subjective gap is a real issue. The tech measures it, but it doesn't judge, and the judging part is exactly where bias and error creep in. So I built something that tries to actually fix that. It's called OffSight. So the problem. The idea is simple. Split the problem in two. First, figure out the objective facts with real math. No AI guessing, so there's zero room for human error there. Then have an AI reason through the actual call the way a ref or a VAR analyst would, transparently, so you can actually see why it decided what it decided instead of just trusting the guy's gut. Now let me show you how it works. So this is our main page. It explains what our service provides and how it actually works, right? And we can just go ahead and launch the analyzer. So here's the app. These are real match situations pulled from actual tracking data. This one's a genuinely midfield foul. These are demo assets, but you can also upload your own clip, which I will show later. So if you take a 3D look here, well, it works for 2D as well. So if you zoom in a little bit, right, there we go. You can analyze each moment and how it worked out in the real. Of course, the 3D asset's a little bit off, but the 2D is more clear. But when I hit analyze, right, you can watch it reason step by step. First, it pulls the raw facts, no opinion yet. Then it grabs the actual law that applies, then it makes a call. Now here's the part I actually care about. It doesn't just stop there, it argues against itself, and during testing, this caught a real bug. And the AI tried to say there's some acceptable margin of error, so maybe it's not really a foul, except that's not a real thing, it just made that up. So I built a consistency guard underneath it, a deterministic check that verifies every claim the AI makes against the actual computed geometry. It caught the AI lying to itself, basically, and corrected the call back to what the math actually said. That's the whole point. The AI can propose things, but it can't contradict the facts. As you can look here, there's the fact extraction, there's the what rule it directs, the verdict it has with a confidence of 0.8, it was clearly a foul in the clip as well, and if there's a possible challenge to it. Now, it's a foul completely, right? And then we also have the upload option. Now, all of this is instant because it's preloaded, but I also wanted to show a real video clip working. Now, this is the video clip I'll use. It's clear offside. Now, this takes some time, so I'll just let it upload while I talk more. But I also wanted, so while that's cooking, let me actually explain how this is built, because there's a few layers here. Bottom layer is pure geometry, no AI at all. I take real tracking data, normalize the coordinates, reject outliers, because raw tracking data is genuinely noisy, and compute things like the offside line and contact distance with actual math. That part's deterministic and fully tested. On top of that sits a 5-agent pipeline using Claude. One agent extracts facts, one retrieves the actual rule, one makes the verdict, one argues the opposite side, and one reconciles everything into a final call with a confidence score. If it's generally borderline assessable, it does not fake certainty. Then above all of that, it's the consistency guard I just showed you. It's the thing that keeps the AI honest against the geometry. For the video upload specifically, I'm running real computer vision, soccer nets tracking pipeline, detecting every player, calibrating the camera, building the whole scene from raw footage into a JSON. That's generally heavy compute. Dual keypoint calibration on CPU took like around 20 minutes for a short clip, so I moved that part onto a GPU worker running on Google Colab, and it talks to my hosted backend through a tunnel. Frontends on Vercel, backends on Render, and the actual CV inference runs on a GPU working on Google Colab locally. So let's check on that upload. Now the upload usually takes like around 2 to 5 minutes depending on the size of your clip. And here we go. So if you look into 3D, there we go. We can clearly see this is an offside, right? Yeah, it was an offside clip. Now we can do a little, and then you can click analyze, right? So if we click analyze, there it is. The same reasoning pipeline, same consistency guard, just built from a video instead of preloaded data. So yeah, that's offsite. Now again, if you want to take a look again, the rule retrieval, the verdict, it explains everything if you don't agree with it and if you want to understand it better, as well as the offside line and etc. So yeah, real geometry and an AI that argues against itself and a guard that keeps it honest and it works on actual footage. Now, if you don't agree with the referee, you can upload your clip and you can understand why the referee made that choice or why it could have been a different choice. And maybe one day this can be implemented in FIFA. Thanks for watching.